What was delivered on Macy's downtown Seattle is the LaserBlade xs4 cells, as you see here. 6 fixtures with 2 power supplies like the one here, which is an ELDOLED Eco Drive at 700 milliamps. So we have 6 fixtures on 2 power supply. The intent was to have 3 fixtures connected in series to a single power supply. We're going to do a few tests here today to show you the difference in light levels when we connect fixtures in series versus in parallel. This is going to be our benchmark test where we have a single fixture connected to the power supply. It is driven at 700 milliamps, which means the fixture is at full intensity. We're going to turn off our ambient light and we're going to measure the light level of a single fixture with our reader, which is going to be 22 inches away from the source. With a single fixture positioned above the reader, we obtain 130 foot candles. So what we now did is connect 3 fixtures in parallel to a single of those power supplies. As you can see, all 3 fixtures are functional. What will not be necessarily visible is that the light level is significantly beneath what it should be when we have a single fixture to the power supply or the 3 fixtures connected in series as they should on the power supply. And the reason for that is when you're dealing with constant current, doing in parallel connections as we have here, as you can see, all positives of the fixture connected to the positive of the power supply and all the negatives of the fixture connected to the negative of the power supply. What happens in a wiring like that is the drive current is going to be split evenly among the fixtures that are connected in parallel. In this case, we have 3 fixtures, so the 700 milliamp divided by 3 reaches about 233 milliamps per fixture. What we're going to do is bring you in front of the light meter again to show that each fixture is going to have a significant less output. Since we have 3 fixtures connected and our benchmark was only a single fixture, 2 of those fixtures are going to be held by my assistant Sebastian here in a different direction so that we can really just measure the light output of a single fixture. Go. So with a single fixture, or in our case, a single fixture at 233 milliamps or 3 fixtures connected in parallel to a single 700 milliamp power supply, thereby getting 233 milliamp per fixture. Each fixture now at full intensity gives us 42 foot candles, or about a third of the 130 foot candles we had measured with the fixture at full intensity. Our third and last test will have the fixtures wired in series as they should, and we will run this test again to show you that we will reach the 130 foot candles that we originally had. So we now have in front of us an in-series connection. The way an in-series connection is wired is we start at the positive of the power supply and we go to the positive of the first fixture. The negative of the first fixture goes to the positive of the second fixture. And the negative of the second fixture goes to the positive of the third fixture. And the negative of the third fixture goes back to the negative of the power supply. Contrary to an in parallel connection where all the positives are bunched together and the negatives are bunched together, this is an in-series connection. Next, we're going to turn off the light and measure a fixture over our light meter to determine the light level. Go. So with a single fixture above our light meter, we reach back approximately the same light level as we had originally. Here we have 120 foot candles. When we had the single fixture on the power supply, we were at 130. This may be due to a variety of factors, including the positioning of our light meter. However, you can see that the difference between the 120 or the 130 that we read when we had a single fixture to the power supply or 3 fixtures connected in series is a lot closer than when we have 3 fixtures connected in parallel, where we reached 50 foot candles at the same distance. It is therefore clear that if you have 3 fixtures that are functioning but that are not at their optimal light level or that appear to be quite dim, that the fixtures are indeed wired in parallel on site instead of being wired correctly in series. Thank you.